The Bluegrass Chemical Agent Destruction Pilot Plant, or BGCAPP, is a state-of-the-art facility which is destroying 523 tons of chemical weapons stored at the Bluegrass Army Depot near Richmond, Kentucky, in a safe and environmentally compliant manner. The stockpile at the depot originally consisted of chemical agent configured in 155mm projectiles containing mustard or VX nerve agent, 8-inch projectiles containing GB nerve agent, and M55 rockets containing VX or GB nerve agent. Protection of the environment surrounding BGCAPP is one of the project's top priorities. Personnel must ensure the plant is following all issued environmental permits and must continually monitor destruction activities to ensure operations are safe for the workforce, community, and environment. For Environmental Specialist Griffin Smar, safety is the top priority in the chemical weapons destruction process at BGCAPP.
Here at BGCAPP, we really pride ourselves in our safety culture. Everybody seems to really care about each other and the environment, which is great. And this plant is the best example of environmental responsibility that I've ever seen. I'm pretty proud of my team. The culture here is fantastic, and really everybody here in the back of their minds has community in mind. It's not about production, it's about environmental safety and getting the job done in a safe and healthy manner.
Operations at BGCAPP began in 2019 and are scheduled to complete by the Chemical Weapons Convention treaty date of September 30th, 2023. The team successfully destroyed all projectiles containing chemical agent, as well as M55 rockets containing VX nerve agent, and is now destroying M55 rockets containing GB nerve agent. This video focuses on the steps to destroy the M55 rockets using neutralization as the primary destruction technology. To start the destruction process, munitions are loaded into enhanced on-site containers, or EONCs, at the Bluegrass Chemical Activity Chemical Weapons Storage Facility igloos. The EONC is a transport container designed for the safe transport of chemical weapons. EONCs are also designed to mitigate chemical agent leaks if the container is subjected to an accident or if there is an inadvertent leak during the transport. At the plant, the Container Handling Building, or CHB, is the area where chemical weapons are first delivered and received. The EONCs are stored in the CHB to allow for continued processing. When the processing line is ready, EONCs are moved from the CHB into Unpack Area 1 inside the Munitions Demilitarization Building, or MDB. The MDB contains handling and processing equipment for the disassembly, neutralization, and decontamination of chemical weapons. During operations, chemical agent will be removed from rockets and neutralized within the MDB. Rocket processing starts in Unpack Area 1, where the EONC is monitored for chemical agent prior to opening. If no chemical agent is detected, unpacking operations begin. Personnel unban the storage pallets, individually remove rockets, and place the rockets on an input cart. Once the input carts are loaded, workers transfer them to the Rocket Non-Destructive Examination, or RNDE. The RNDE is a fully automated X-ray process used to detect the presence of liquid chemical agent in the interspatial area between the shipping and firing tube and the rocket. An image will be presented to an operator on the local X-ray monitor for examination, at which time a selection of pass, rescan, or fail can be made on the monitor. If pass is selected, a robot picks up the rocket and places it on the output transfer cart to be taken to the rocket input assembly lines. If rescan is selected, the rocket will remain in position and the X-ray process will restart. Multiple rescan attempts can be made until the operator is confident in their selection of either pass or fail. If fail is selected, the robot will pick up the rocket and place it back in its original position on the input cart. Munitions experts will determine if the rocket can be safely processed or if it needs to be overpacked. Overpack operations will take place in Unpack Area 1. These overpack rockets will be sent to storage or directly to the Static Detonation Chamber, or SDC-2000, for destruction. Once this evaluation is complete, the rocket will be transported to one of two rocket lines for processing and conveyed to the Explosive Containment Vestibule, known as the ECV. The MDB contains two ECVs. In these rooms, the rockets are processed in the Vertical Rocket Cutting Machine, or VRCM. A robot loads the rocket into the VRCM. The cutting wheel rotates around the rocket, making the first cut through the shipping and firing tube. The top portion of the shipping and firing tube is removed by a robot and placed on a conveyor. A second cut is made to separate the rocket motor from the rocket warhead. The rocket warhead is picked up by the robot and placed on a conveyor for transport to the adjacent Explosive Containment Room, or ECR. The VRCM raises the rocket motor still contained in the lower portion of the shipping and firing tube to be picked up by the robot, which then places it on the same conveyor as the shipping and firing tube. Potentially contaminated rocket motors identified before, during, or after rocket cutting will be transferred to an overpack for later processing in an SDC unit. The rocket motor contained in the lower portion of a shipping and firing tube with attached end cap is conveyed by automated equipment and packed into wooden boxes in the motor packing room. Each box is capable of holding up to 30 rocket motors. Once full, the container of rocket motors is monitored to confirm no contamination, then transferred to the motor shipping room. Boxes of rocket motors are transferred to designated non-contiguous storage igloos to await destruction, or are directly transferred to the non-contiguous SDC located in Anniston, Alabama for destruction. At the Anniston SDC, destruction of the rocket motors is achieved by heating the items above its auto-ignition temperature and deflagrating the components. The empty shipping and firing tube half with attached end cap from the first cut of the rocket is transferred to a roll-off storage container for eventual transfer off-site to the Veolia Treatment Storage and Disposal Facility located in Port Arthur, Texas for destruction. The MDB contains 2 explosive containment rooms, or ECRs. In the ECR, the rocket warhead is punched and drained of its chemical fill at the punch and drain station. After draining, the warhead is placed into a canister. While this is occurring, a pallet of empty canisters is transported from Unpack Area 2 by automated equipment to the tray container transfer room. The pallet enters the Energetics Batch Hydrolyzer, or EBH room, where it is forwarded to the pallet depallet area. A robot removes a canister from the pallet and places it on an Autonomous Mobile Robot, or AMR. A robot then picks up the empty canister and places it in an airlock. The robot removes the canister from the airlock, places it in the crimping station, and removes the cap from the canister. A second robot picks up the drained warhead and places it in the canister at the crimping station. Once the warhead is inserted, a robot places the cap on the canister. The crimping station hydraulically crimps the canister to seal the warhead inside. At the crimping station, the containerized warhead is raised in a vertical position for the robot to pick up the canister and move it to the airlock. Inside the airlock, a scale reads the weight of the canister. Drained agent is transferred to the agent collection system. During the punch and drain process, the rocket warhead is irreversibly mutilated. At this point in the rocket destruction process, the chemical agent has been drained from the rocket warhead and collected for processing. All other components have either been partially or completely mutilated, rendering them incapable of further use. As such, credit for the destruction of the rocket and the chemical agent fill is taken at the punch and drain station, subject to the requirement to continue verification of the destruction of the rocket components. Systems engineer Steve Frank discusses the programming and deployment of robots for the rocket processing system at BGCAPP.
My favorite thing about my job is creating automated solutions for complex problems. The rocket handling system brings us new challenges every day due to its complexity. We face those head on, and we do it by being very intentional with everything that we do and to have very good situational awareness of everything around us. This project is important because we are destroying chemical weapons that can be never used against humanity.
The International Oversight Group, known as the Organization for the Prohibition of Chemical Weapons, or OPCW, monitors the destruction process as part of the Chemical Weapons Convention Treaty, which bans the development, production, storage, and use of chemical weapons worldwide. Sampling of chosen treaty-tagged rockets occurs at the punch and drain station. Highly trained personnel conduct toxic area entries into the ECR and obtain a sample of chemical agent from a chosen treaty-tagged munition. The OPCW inspection team witnesses the collection of the chemical agent sample via closed-circuit television in the treaty office facility and physically witnesses the sample analysis in the laboratory. After draining and containerization is complete, the warhead is transferred from the ECR to the EBH room to be packaged in a pallet. In the EBH room, the containerized drained warhead is transferred to the label station by a robot. The canister is then placed on an awaiting AMR for transport to another robot, where the canister is placed in a pallet. Once full, a label is applied to the pallet and is transported through an airlock to Unpack Area 2 before being transported to a designated non-contiguous storage igloo or directly to an SDC unit at BGCAPP for processing. The Agent Collection System collects agent drained from rockets to await processing in the Agent Neutralization System, or ANS. The ANS is used to neutralize chemical agent. VX and GB each have a unique batch recipe that consists of a mixture of water and sodium hydroxide. To start the neutralization process, an agent hydrolyzer is filled with processed water. The hydrolyzer is then filled with caustic, agitated, and recirculated while heating to reaction temperature. Agent is then transferred by the ACS agent feed pumps into the ANS recirculation loop. The agent passes through a static mixer to cause a chemical reaction to break down the chemical agent. After the reaction is complete, the batch is cooled. VX hydrolysate is sampled directly from the hydrolyzer. GB hydrolysate is transferred to the sample tank prior to sampling. This allows another batch of GB to be processed in the ANS. The chemical agent is destroyed in an irreversible manner through low temperature, low pressure neutralization to ensure agent destruction to less than 1,000 parts per million or 0.1% agent per weight. If sample results still indicate the presence of chemical agent that is above 1,000 parts per million, the batch will be reprocessed with additional caustic. If the sample results pass or are below 1,000 parts per million, the batch is transferred to the hydrolysate storage area, or HSA. In 2020, a decision was made to not use supercritical water oxidation, or SCWO, to further process hydrolysate on-site after operational issues were encountered during testing. It is shipped off-site for destruction instead. The hydrolysate is routed from the HSA tanks through the repurposed SCWO processing building. The SCWO processing building contains piping that routes agent hydrolysate to the truck loading station and a control room to support tanker loading operations. For outside operator Tony Likens, the positive working environment is one of the best parts of being at BGCAPP.
It has been really interesting here at BGCAPP to see the physics involved in destroying the chemical weapons. One of the things I really like here at BGCAPP is the teamwork. A lot of the guys here have a really good rapport, and it makes for a great work experience, and it's really a nice environment to get things done. It gives a profound sense of pride and accomplishment in seeing the chemicals actually be destroyed and eliminated in an environmentally acceptable fashion.
The hydrolysate tankers are shipped off-site to the Veolia Treatment Storage Disposal Facility located in Port Arthur, Texas for destruction. The Control and Support Building, or CSB, contains the main plant control room, as well as the Demilitarization Protective Ensemble, or DPE, support area. The control room is the central location from where the plant processes and equipment are controlled. Operations are continuously recorded and archived in the control room. The DPE support area is where entries into the MDB toxic areas are planned. These areas are maintained at a positive pressure to ensure the safety of the workers inside during any type of upset conditions. Mechanical technician Charles Richardson talks about his first time getting into a DPE suit and the safety focus of the extensive training workers must complete to safely accomplish their tasks.
The first time I got dressed in a DPE suit, very nervous, wasn't sure how I was going to react. After I got in it, started moving around, I don't really know how to put it in words. It just felt right. It's very, very safe driven. There's a lot of people that I'm friends with around the community. The most common question that comes up is, do you think that it's safe? And I'm 100% confident that it's safe.
SDC units are used to further process drained containerized rocket warheads. The SDC is designed to destroy chemical agent, chemical weapons, and associated components by indirect heating in a detonation chamber. Destruction in the SDC units is achieved by heating the item above its auto-ignition temperature, deflagrating or detonating the energetics, and thermally treating the chemical agent. The off-gases generated from this disposal process are cleaned and filtered in an off-gas treatment system. In 2019, due to worker safety concerns, a decision was made to no longer use the energetics neutralization system to process M55 rocket warheads in which nerve agent had been drained. Instead, these drained warheads will be processed in the SDC-1200 or the larger SDC-2000, which will also be used to destroy the overpacked M55 rockets. The SDC-1200 unit was originally installed to destroy the mustard agent projectiles. Mustard projectile destruction began in 2019 and was completed in September 2021, marking the elimination of all mustard agent in Kentucky. The BGCAPP site encompasses 48 acres, 18 of which are within the existing Bluegrass Chemical Activity Chemical Limited area. The SDC-2000 facility is located on the north side of the BGCAPP site. The SDC-2000 facility consists of an enclosure building to house the SDC unit and off-gas treatment system, and several other support facilities. In addition to the buildings needed for operations, BGCAPP also has several support buildings that are essential to the mission of destroying the chemical weapons stockpile. The medical facility is staffed 24 hours a day, 7 days a week. The medical facility is capable of handling both clean and contaminated patients and offers both emergency and occupational health care. This facility is equipped with an on-site ambulance to transfer patients requiring additional medical care to local hospitals as needed. All contaminated patients are decontaminated prior to any transport required for additional medical care. Paramedic Marissa Newby talks about the unique relationship the medical department has with the workforce at BGCAPP.
So my role in this historical mission and the role of my department really has to do with preserving the health and protecting the life role of the people who are helping destroy these chemical weapons. In the medical department, we get to know everybody on a more personal level. I think you can develop that sense of brother's keeper in a really different way. It makes it unique, and it gives us a unique relationship with the site and the project and the people that really kind of make this mission possible.
The laboratory houses all the chemical and analytical support functions associated with air monitoring, secondary waste characterization, agent standards preparation and verification, and depot area air monitoring system analysis. Lab analyst Jesse Holmberg gets to work with interesting people and equipment in the BGCAPP laboratory.
What I like about working here at BGCAPP has to be working with all the different equipment. There's a lot of people here willing to help me, to teach me about the ins and outs of all this stuff. And it's also cool to tell my friends that I work with Nerve Agent. I feel pretty lucky to be part of the team destroying the rest of the stockpile of the U.S. I feel lucky to be a part of such a big mission, take care of some really nasty stuff that's out there.
Additionally, treaty agent sample kits are prepared in the laboratory. These agent sample kits contain the tools and equipment needed for personnel to safely obtain a neat agent sample from a drained rocket warhead within the MDB. The sample is then transferred to the laboratory for analysis and witnessed by OPCW inspectors to confirm chemical agent type. Maintenance technician Jordan Medina thinks it's important to destroy the chemical weapons.
Most interesting thing about my job, I have to say, the way the whole system works. All the equipment that goes into getting rid of all these weapons. I like just about everything, and it's a wonderful thing taking part of this. It's very special, getting rid of all these things. We don't need them. So, make the world a better place, make everybody feel safer.
In April 2022, the team finished destroying all M55 rockets containing VX nerve agent, marking the elimination of all VX nerve agent weapons in the United States chemical weapons stockpile. M55 rockets containing GB nerve agent are the last munitions to be destroyed in Kentucky. The Bluegrass Chemical Agent Destruction Pilot Plant team is on target to honor our commitment to the local community, the nation, and the world to be chemical weapons free by September 30th, 2023.